Hey, so the focus of this lesson is about we're just giving some strategies and some practice with the idea of what we call modeling a linear system, which means you're given some sort of scenario and you want to try to find a way to create a model of it using equations, linear equations. And in general, your goal is to come up with a linear system that has two equations and two variables that somehow connect to the relationship shown. And if you can create a model, then you should be able to solve it, if nothing else, with Desmos, and that solution should tell us something. Well, the focus of this is mostly just on about how do you create these equations. So first, what I have here are some strategies to model a system of equations. Try the following. First, and I'll model these steps for you. First, always determine and write down, even if it's obvious to you, write down what the two unknowns are in the question, because these two unknowns will be related by two different variables. And while you could always call one variable x and one y, I would in general try to pick variables that you think, or pick letters for your variables that relate to what they represent. So if one is time, pick t. If one is cost, pick c, in general. Once you know what your two variables are going to be, and sometimes that's quite obvious and sometimes it's not at all. The best way of approaching this is just to look at a variety of problems. But once you have your two unknowns, then you want to try to find an equation that connects two of those variables together. And once you have one equation that connects two variables together, you need to find a second. If you have two unknowns, two variables, it's not possible to figure out those unknowns unless you have two equations. Anyhow, let's get straight to it. So here's an example of a question. I'll read it out. A movie theater charges $11.25 for an adult ticket and $8 for concession tickets. Concession being like students or seniors and whatnot. Suppose 240 people attended a particular showtime which earned $2,433.50 in revenue. So that's how much money came in during that one showtime. Okay, so your goal here is to write a system of linear equations to model this. And so first, what are my unknowns? And in this case, I mean, there's many things we don't know. So perhaps I should say, what are the unknowns in this that we know we can eventually figure out? When I say unknowns, like we don't know what the movie was, but that doesn't matter. The two main unknowns here are the number of adult tickets sold and the number of concession tickets sold. And so let me write that down here. So first, the unknowns. So for the number of adult tickets sold, I'm going to use the variable a. So number of adult tickets sold. And then I'm going to use c for the number of concession tickets sold. And if I were to use x and y, my question is, well, why? But if you want to be really clear about what x stands for and what y stands for. Okay, but I think it's pretty clear. A is the number of adult tickets that were sold, and c is the number of concession tickets that were sold. So, okay, that's a first big hurdle. And again, I can't expect that to be obvious. Those are our two unknowns. But those are the two things we don't know directly in the question, but we do have enough information to figure out. So I need to find an equation that connects these together. And one would be by what it says here, that each adult ticket costs $11.25, each concession ticket costs $8, and altogether, that showing made over $2,000 in revenue. So how can I put that together into one equation? Well, if I say 11.25 times A, $11.25 for every adult ticket, plus 8C, $8 for every concession ticket. I don't know how many tickets were sold, but I know how much each ticket costs, and I know altogether that made $2,433.50. So there's one equation that relates back to the information. If I just look at this one equation and I want to figure out what is A, what is C, I don't have enough information yet, because I need another equation. The other equation comes from this. 240 people attended this particular showtime. So if 240 people attended, well, that means the adults and concession tickets together equal 240. So my other equation would be, I could say A plus C equals 240. And now, notice I have two unknowns, A and C, but I have two equations. And so there must be a way of solving this. Now at this point, I think the hardest part and the most important part of the question is done. And that was coming up with this system here. Okay, that's done. I don't expect that to be easy, although the more examples we see, for example, if we see another problem where we talk about two different types of tickets, then it definitely becomes easier. I mean, there's certain types of problems we can look at, and when you see something similar, that makes it significantly easier. What I want to do now is I just want to solve this in Desmos and think about what the solution represents. Now, when I go into Desmos, I can type A and C, but it's easier to type X and Y. So going forwards, X is going to stand for my adult tickets, and Y is going to be concession tickets. So if I go into Desmos now, that's what I have graphed right here. Now, it actually has been graphed. One's in red, one's in blue. But I don't see anything because, well, my x-axis represents the number of adult tickets. The y-axis is number of concession tickets. I'm not looking at, if I look at my graph here, I'm only seeing up to 10 in each. So I need to zoom out first. There we go. Now I see something all right. And I may want to adjust my scales a bit. I'm going to stretch just the x and y scales a bit. That's a pretty good graph right there. Okay, so with that said, what's my solution? My solution is 158,82. Okay, but what does that mean? Well, again, in some scenarios, it may be really obvious what that solution means. In others, it may not be clear at all. But that solution means something. And in this case, that solution means my x-coordinate is 158. That was the number of adult tickets. And so I now know 158 adult tickets were sold and 82, which was my y, which I said is my concession. That means I know I sold 82 concession tickets. So that's what this tells me for this particular system. And any question that's set up like this, any question where you don't know how many tickets were sold, there are two types. Your coordinates of your intersection will tell you how many were sold. I now know 158 adult, 82 concession. All right. So with that said, if I go back to this, the hardest part of the question, I think, and the most important part of the question right now, was figuring out this part right here. And if you, again, found that challenging, fair enough. But like I said, if I gave you another question just like this, or maybe tickets to some other event with different monies, I don't think you'd find it so hard anymore. You have a structure to base on. And so the best way of approaching these questions is first to see a variety of them. That's it. I just want to look through one more together for our notes. And this has to do with two people running a race at different speeds. Another common type. All right, so let me read it. Amy and Beth, A and B, are competing in a 10-kilometer race. When Beth is 2 kilometers from the finish line, she is running at a speed of 14 kilometers per hour. At the same time, Amy is 500 meters ahead of Beth, but is only running at a speed of 11 kilometers per hour. So write a system to model this problem. All right, so first, what are my two unknowns here? Well, anytime in general we have a question about two people or two objects moving, and we're trying to find when one connects to the other, the two things we're connecting are time and distance. So my two unknowns, one of my unknowns is going to be time. I'm going to use t for time, but if I just put time, that's not very clear. Like, what do I mean? Time, well, it's time from something. We could say time from the start of the race, but the question, we don't really know what happens at the start of the race. All we know is the question really kind of starts off from the point when Beth is 2 kilometers from the finish line. That's when all this stuff comes into play. So I need to be clear here so I know what my variables stand for. So t is going to be time, but not time from the start of the race, not the time of day, but the time in hours. I want hours because my units of speed are in kilometers per hour. So I want time in hours from the moment the question started. So when did the question start? The question starts when Beth is 2 kilometers from the finish line. So time from when Beth is 2 kilometers from the finish. And so that's already something fairly tricky, because it's easy to say time, but time from when? And again, everything you're given in the question kind of begins the moment we say that Beth is 2 kilometers from the finish line. At that instant, I tell you the speeds and all these things. Okay, so time is time in hours for when Beth is 2 kilometers from the finish. My other variable is going to be d for distance. And again, I have a choice, or I need to think about distance. What do you mean distance? I could say distance from the start, which is what I'm going to do, from the start of the race. I could say distance from at the instant Beth is 2 kilometers from the finish. Again, I have a choice. I just need to be clear. Just saying time and distance without specifying time from what, distance from what, can easily become confusing, especially for yourself. All right, so how do I create two equations with this? Well, in this case, there's kind of two sentences, one about Beth, one about Amy. So let's write my equations like this. So one equation is about Beth. One equation is about, one equation and one sentence is about Amy. So looking at Beth, let's see this part here. When Beth is 2 kilometers from the finish line, she is running at a speed of 14 kilometers per hour. Okay, so I can now say for Beth, her distance, the instant she was 2 kilometers from the finish line, that means she's already traveled 8 kilometers. So I'm going to put 8 plus, because it's a 10-kilometer race. And if I'm choosing distance to be distance from the start, I have to take into account that she's already run 8 kilometers. So the distance Beth has traveled is 8 plus, well, what's next? She's traveling 14 kilometers an hour. So that means 14 times the time she's running will be the distance she travels next. And one thing you always want to remember is, I'll put a little note off to the side here, that distance equals your speed times time. And so again, the distance Beth travels is at any given time is going to be her speed, 14 kilometers an hour, times the time. And again, the time is changing from the moment we're talking this question starts. The race is still progressing. So with that said, if we have that, Amy's should be relatively simple because it's so similar. So Amy, her distance is going to be, at the start of the question, it says right here, she is 500 meters ahead of Beth. So she has traveled 500 meters more than Beth at the instant this question starts. So when Beth has traveled 8, Amy has traveled 8.5 kilometers. Right, a kilometer is 1,000 meters, so 500 meters is half a kilometer. So Amy has traveled 8.5 kilometers, plus her speed is slower now though. She's traveling 11 kilometers per hour. So 11 times t will be the distance she travels after some amount of time. And again, this is the hardest part of the question done. And this is the most important part of the question done. And all questions that involve some sort of comparison between two objects moving over time, it's a fairly common type of question where there's two objects, one's maybe going faster than the other, so at some point one's going to catch up. This sort of setup is pretty common. In this case, one has sort of a head start. Amy's a bit farther ahead, but Amy's traveling slower. All right, so with that said, that's the most important part of the question done. But like before, I will graph this, and we want to think about what this solution means. And keep in mind, on my graph, I'm going to call time x and distance y. Although I can type in Desmos, I can type in d and t, but it's just set up for x and y a little faster. So as long as I know x is time from the moment Beth was 2 kilometers from the finish line, and as long as I know d is distance from the start, I can use x and y. All right, so let's go here. Let's turn this off and look at these. Okay, so like before, I need to adjust my settings. If I go back to the basic zoom setting, I see this. That's like, let me kind of zoom and stretch these a bit to see my graph a bit better. There we go. So let's look right there. So that's my solution. 0.1667, 10.333. So what does that mean? Well, this means the instant, well, this essentially tells us the instant the two runners, according to our system, are right beside each other. All right, this essentially tells us the moment Beth and Amy meet up with one another. And I know that it occurs at these coordinates, but what do the coordinates mean? The x coordinate is time. So 0.1667 hours from the instant this question kind of started, from the instant Beth was 2 kilometers from the finish line. At that instant, 1.16 hours, they've met up. So what does the 10.3 represent? The 10.3 repeating, that represents the distance they've traveled in total from the instant they meet up. So this means that Beth catches up to Amy 0.16 hours from the moment this question started, and they had both traveled 10.333 kilometers at that point. Well, don't forget the race is only 10 kilometers long. So really what this tells us is, even though theoretically Beth will eventually catch up, she won't catch up before the race is over. So this tells me that Amy still beats her. All right, because again, Beth will catch up, but theoretically she'll catch up, I should say, but by then the race is over. The race is only 10 kilometers long, and remember my y coordinate, I chose my y coordinate to equal the total distance of the race, and I can clearly see at that point they've traveled more than 10 kilometers. And so I now know with certainty that at this rate, Amy will still win. But again, that coordinate of solution means something, and quite often it's quite challenging about what it means. And if I wasn't clear about what T and D represented, then it's really easy to be completely unclear about what this means. All right, so the best way of approaching questions like these is to keep trying different ones. I've shown you 2 examples here. And there's, there's not a huge variety of types of questions, but these are 2 fairly common ones. All right, but I'm going to stop here.